Dear students, good evening. Last class we discussed about vernier calipers, right? Yes. Last class we discussed about vernier calipers, right? The subject, the subject name, industrial instrumentation, right? The main purpose of this vernier calipers is to measure the diameter or any thickness of the glass material or radius, isn't it? Or volume of the unknown sphere. Like this, we can easily measure it with the vernier calipers, right? This is one subject, but one more subject is PC-based instrumentation. This semester, in this current semester, I am going to handle two subjects. One is industrial instrumentation, and one more is PC-based instrumentation. So, what is PC-based instrumentation? So, you see that the syllabus of this PC-based instrumentation, right? Because you selected this selective subject among the four, right? PC-based instrumentation, right? So here also we have four chapters, unit 1, 2, 3, 4, right? And what exactly the meaning of PC-based instrumentation? So the name itself says that it is an instrumentation subject. There is no doubt it. It is an instrumentation subject, right? So here the subject deals with instruments, no doubt it, instruments. But apart from these instruments, this subject mainly focus on computer system. Computer system. That means the instruments which are working, the instruments which are useful for knowing or measuring or monitoring or controlling or doing some action, all the instruments could be connected to the computer system. Connected to the computer system. So without computer, here no instrument is going to work for any operation. For any operation. So the subject, the name itself says that PC based, system based, computer based. So with the computer system, all the instrumentation is going to be working, right? Suppose I want to control the movement of the any ladder. I want to control the movement of any uh, a motor, any electrical motor, or I want to control, say uh, some a part in the industry, any one of the part in the industry, or any velocity. I want to control it, right? I want to displace it. I want to switch it, or I want to switch off this. So if I do any action with the instrument, that instrument should be driven by a computer system. Driven by computer system. So without computer output, without computer instructions, no instrument is going to be working. So the name says that PC based, computer based instrumentation. So you can understand the difference between other instrumentation and PC based instrumentation. So what is other instrumentation? If you observe any, say for example, say measurement of flow, measurement of flow. So we can use electromagnetic flow meter. It is a instrument or it is a transistor, but it is not controlled by the computer system. It is not controlled by the computer system, right? So that is also instrument, but it is not controlled by the computer system. But some instruments are mainly controlled, connected, interface to the computer system. So because of this interface, all the instruments are working and and so that you can control any one of the parameters or action, right? So these systems are very much useful in the automations. In the automations, that means control system, right? What automation? Without manpower. So everything, all the actions, all the control actions, they are going to be controlled in the system itself. Of course, no doubt, there should be intermediate device or instruments. Instrumentation techniques, we have to follow it, definitely. But all the instruments are driven by this computer system. So it came as PC-based instrumentation. You remember, you see that the syllabus here? In this unit 1, the unit 1 of this PC-based instrumentation completely describes about uh, the general information regarding what is a computer system, what are the inputs, what are the outputs, what are the ports, and what are the standards we have, isn't it? What is addressing, what is data, like this. So these are all covered in the unit 1 of 50% of the syllabus. So the remaining half of the unit 1 starts with programmable logic controllers. Programmable logic controllers, right? So this PC-based instrumentation mainly focused on programmable logic controllers. So they are nothing. They will give you some actions for controlling any parameters, right? And see, the unit two covers PLC intermediate and advanced functions. How this PLC will function, will acting to other devices. How it is acting, how it is going to be give some functions to the devices. Third chapter deals with applications. Applications means with this programmable logic controllers, how we can uh, do some uh, real time devices or real time systems. So we can control all these with programmable logic controllers. And we have one more data access system, nothing but supervisory data control, digital control, that is called SCADA. So, so these all these chapters mainly focus on you have to control all the actions in the industry with computer system. So with the interface of the computer, all the logics, all the functions we have to set such that all should be controlled automatically. So it needs, if you want to control any actions automatically, we need programmable logic controllers. All should be driven by a computer system. Remember, this point is important. You take any controller, program logic controller or supervisory controller, any control actions are driven by a computer system. Programmable a computer system. You can program it, you can save it, you can do some, you can save or modify any program that will help giving some actions to the PLC such that it is going to be working for controlling in the industries. Right? This is about the syllabus available in this subject. It is very easy, but we have to focus on different different functions of the PLCs. Right? We'll see later about this. Okay. Then uh, okay, sorry for the disturbance. Right? That is the syllabus we have. Nana, in this comma, in this comma. Okay. Uh, Today we see uh, in the computer organization. In the computer organization, uh, you know what is a computer, what are the basic diagram of the computer system, and what is addressing modes, and what is address bus, data bus, isn't it? And what is memory, types of memories, these are all covered, right, in the CO. Of course, don't worry, I will also cover in the subject. But today we'll see what do you mean by PLC? What do you mean by PLC? PLC nothing but see a programmable logic controller. A PLC is a specially designed digital operating microprocessor based controller. So it is a one type of controller that uses a programmable memory for internal storage of instructing and for implementing functions such as logic, sequencing, timing, counting, and arithmetic in order to control missions and process. That means with this PLCs, of course, in your class, there are some students are available, maybe lateral entry students, I think so. I think these are covered in the diploma level. Or if you take any course on these PLCs, some outside this, there are some courses are available for this. Yes, it can practically you can observe all these PLC concepts. So remember the main function of this PLC is it provides some logic. It provides some timing. It provides some counting, and it provides some arithmetic actions, arithmetic functions. So how it provides all this? So we need some a system, supported system, PC based, so called PC based. So it is a controller will be driven by this computer system like this. See the diagram, basic components of a PLC. These are the basic components of the PLC. So what are the basic components we have? Yeah, yeah. The PLC hardware system consists of the following components. One is processor. One is processor. Next one is memory. Next power supply. Then input modules, output modules, programming device, and monitor. And see the diagram. The same is depicted here as a PLC. Is a PLC hardware. So these are the input sides and these are the output sides of inputs. It accepts some inputs. So here we are placing push button, limit switch, push buttons like this. So it will accept some inputs, right? Based on that inputs, they are processed here. They are processed here because it is a processor. It is a simple computer system. It is a computer system, CPU, central processing unit, and a memory, user memory and data memory, and some input output ports. These are called serial ports, interfacing purpose. Ports are available, and for working of this PLC, we need some power supply. Here we have a power supply, and once the input is accepted by this PLC, right, that is processed here, and it will give some actions as output. What action? Action may be a logic or any sequence or any timing or any maybe counting or any arithmetic or any control mechanism like this. So it gives an output that is based upon that output, the remaining, the succeeding, I mean, of that remaining system or any activity is going to be controlled, right? So that if you want to change any, if you want to change any data, any programming, if you want to change it, action is going to be changed. We need some programming device, so we can program it. So for this purpose, we need a memory, volatile and non-volatile memories. But we can write it, we can read it. So there should be some possibility of this memory, right? So it will be done with the help of programming device, right? Like this. See, these are all the devices are available: processor, memory, power supply, input, output models, programming device, and monitor, right? So, what is the processor here? What is the main purpose of this processor of the PLC? Generally, any PLC may have a processor. As you said, you know that any PLC should be driven by a system. So, system has some processor, right? It is a processor. Uh, this processor processes the signals from input module, process the input model and generate, this point is important, and generates controlling signals for the system. So the PLC gives some controlling signals for the system. So what action you want? What action you want? So it will convert that signals with the processor, and it also scans and solve the logic of the user program. So if you want any scanning or if you want to solve any logically, the processor will do all these functions. And the processor generally consists of arithmetic logic units, microprocessor units, memory unit, and system power supply. So in this processor, these are all available. All these sub modules are available: ALU, microprocessor unit, memory unit, and system power supply. Okay, of course. And second part in this PLC is memory. So in this memory, the memory unit contains the program stored. So it is a storing place. Memory is a storing place, right? You can store the data permanently. Sometimes you can store temporarily the data if required, right? So for this, the programs were written with control actions to be executed by the microprocessor for the input given, right? And RAM is a temporary storage device used to store ladder diagram and for testing and evaluation. Then it is stored in ROM where changes cannot be done. That means in this memory we can categorize into two, RAM and ROM. So what is RAM? Random access memory. ROM means read-only memory. So there is another name for this RAM. What is another name for RAM? Of course, random access memory. You can access randomly the data. You can retrieve it by applying some address, by sending some address. You can retrieve the data randomly. Of course, fine. But there is another name for the RAM. What is that RAM? Means in the CO subject, you have know all these concepts. What is the RAM? RAM means we can read, we can write it. Read, write memory. Read, write memory. So if you want data, read it. If you want to write, write it. You can store it. You can retrieve it. But in the case of ROM, it is not possible. Random read-only memory means you can read. You can take the data from the memory. You cannot write it. You cannot write it. So it is called read-only. Read-only. Retrieve only. No return. But in the RAM, you can read. You can return. That's the meaning of this uh, memory, right? So how do you store the data into the memory, or how do you retrieve the data from the memory? That depends upon the addressing mode. You know very well about very well in the computer system, computer organization and architecture subject, right? So without address, you cannot uh, retrieve or you cannot write the data, right? So we need some addressing modes. We'll see. Next, power supplies. So you know the importance of the power supply. Any power supply will excite the system. Without power, no system is working. Definitely, we need some power, right? How much power is required? Generally, we have a AC power, right? That should be converted into a required DC or DC power as per our requirement. As per our requirement. So the DC voltage is supplied to the processor and to the circuits, the input and output interface modules. The power supply should be free from heavy loads, noises, and voltage fluctuations. So while any process is going on, any function is going on, any control action is going on, so there should be no voltage fluctuations. If any fluctuations are occurred, noises or heavy loads occur, what happens? So that looks like what is called loading problem. Because of loading problem, the function cannot be done correctly, right? So we have to think about the power supply also. Power supply is very much important in the PLCs. Yeah? PLCs. Next, input output modules. Input output modules. Right. Input modules receives information from extended devices and sends to processor and communicates the processed information to the external devices through output modules. So you know the general meaning of this input model, nothing but inputs. So how do you give input to the sorry? How do you give input to the how do you give input to the how do you give input to the a PLC? How do you give How do you input? See, yeah. So uh, through the input only we can give some many inputs like say for example input may be a mechanical switching or any photo sensor or maybe temperature input or flow other other type of sensors keypad. So these are all acting as input models if required. And output devices may be solenoid valves, relays, contactors, contactors, lights, horns, some heating elements, fans, motor starter, some amplifiers, conveyor belt, lift, automatic doors. So these are all comes under input-output devices, sometimes also called peripherals, right? So we cannot simply say these are, we cannot categorize this is input and this is output. Uh, It may be acting as a peripheral input and output devices. So input models help us to accepting our input. So because of this, once input is accepted, that will process and communicate it to the output, external device. Okay, and then programming device. This is important. Programming device is the important. So it is used to enter the required program into the memory of the CPU. So we have all the devices in the system. Of course, fine. All the devices. We have very good system. We have input and we have output. Fine. But if what action you want to generate? What action you want to generate? Right. So that action, what action you want as output depends upon how we are programming the system. How we are programming the system. Okay. అమ్మ క్లాస్లో ఉన్నా మీరు కనెక్ట్ కండి 7:55 కనెక్ట్ కండి. Okay. So how best you can program so that we can get the required output. That may be sequence, as you know, sequence or counting or timing, any automatic action, any logical action function, isn't it? So that depends upon how best we are programming through this programming device. So it is used to enter the required program into the memory of the CPU. So program is developed in programming device and stored into memory. So once you are programming, that complete program it should be stored in the memory, into the memory. Okay, and see that mm, basic structure or internal structure architecture of the PLC. So this basic structure may include CPU, already CPU, central processing unit. This central processing unit, the CPU controls and process all the operations within the PLC, right? So you can't control any actions, you need a processing unit. You need to control a processing unit. Okay, so it is supplied with the clock with a frequency of typically 1 to 8 megahertz frequency. 1 to 8 megahertz frequency. So this frequency determines the operating speed of the PLC. Definitely, absolutely it is correct, right? So if frequency is more, the what is frequency? Cycles per second, right? Cycles per second. If cycles increases, the speed increases, right? The operating speed also increases and provides the timing and synchronization for all elements in the system. This is very much important in the control actions. So if I give input, if I get any output, that output should be rightly controlled, rightly control the required activity. If it is not unable to control in a certain time, there is so-called That is what is so called. It is not synchronized. It is not synchronized. It is not synchronized the timing also. So synchronization is very much important for controlling the activity of the system, right? And the information within the PLC is carried out by means of digital signals. Of course, you can send the definitely digital signals. The processor is a microprocessor that executes a program to perform operations specified in the ladder diagram or set of Boolean equations. Okay, and the CPU mainly consists of the following: ALU, arithmetic logic unit. So what is arithmetic logic unit? So both arithmetic functions and logical functions. Like say arithmetic means see addition, subtraction, multiplication, division like this. Logic means AND function, OR function, and NAND function. Sorry, NAND function, and uh, okay, and exclusive or XNOR, isn't it? Like this. All these functions we can done with this ALU. And memory unit, just now we discussed about memory unit. So we have this ROM and RAM, right? Maybe read only or read out, can write or read out the data. So we need with this memory unit also include some temporary buffers for storing our input output channels. So definitely we have to use some buffers for storing some data, which cannot be frequently used. So it can frequently use. You can store the sorry. You can store in the buffers and control unit. Control unit. So we need some control section for controlling all the parts within the PLC. Memory unit is also be covered, right? And see that volatile memory or temporary memory, right? Volatile. So volatile memory will lose all its program content if operating power is removed or lost. That's called volatile. Therefore, to provide a battery backup, therefore it is necessary to provide a battery backup power to all the times. So definitely, as in the first statement, there should be no power fluctuation and there should be no memory loss. Memory loss. So in order to uh, protect the memory, we have to go for non-volatile memory device other than this volatile memory. Okay? And non-volatile means what? Permanent storage. Permanent storage. Okay. Okay. Uh, this controls the operation of the PS. It does not lose its content during the power failure. Okay, it does not require any battery. Generally, the ROM memory offers the CPU to use only fixed amount of data. Okay, see that different types of ROMs available. What are the ROMs? Read-only memories, PROM, programmable read-only memory, erasable, programmable, read-only memory, EPROMs, EEPROMs, mask, programmed ROMs, PROMs, EPROMs, EEPROMs, isn't it? These are all you may studied in the computer organization. Buses. What is bus? Bus nothing but a wire. Nothing but a wire. So bus carries human beings, general bus. But computer bus carries data, ones and zeros. Ones and zeros so called data, binary data or digital data. Right? So the bus is not a single wire, it's a parallel line, parallel wires. So set of parallel lines, so called bus. That bus may be connected throughout the PLC, throughout the PLC. That may be CPU, that may be memory, that may be IO units, maybe all devices, all throughout the computer system, all connections are going on. So without connection, no operation. So buses are very much important in this PLC. So what about buses we have? Data bus, address bus, control buses, right? Data bus may be of any length. Length means that's so size. So size. What size? 8-bit size, 16-bit size, 32-bit size. As per your you have to use. 8-bit size refers to the processor size. The processor size. Address also 16-bit size, 20-bit size, 24, 30-bit parallel. I mean size address bus. Control bus is 4 to 10 bits, 4 to 10 bits. So these are the control buses covered. And I/O system bus. Sometimes some bus is connected to I/O system. So they are communicating with input and output devices. Okay, and input output processing, input output processing, right? So we can do all these functions with this PLC because the PLC includes all this a computer system, right? Now I'm going to stop the class, right? Because I have one more class for the final year. Okay, tomorrow we'll see. My intention is parallelly I want to cover both II and PC based instrumentation, right? Uh, okay, if you have any doubts regarding this, you can ask me. I will I will clear all your doubts, right?